The image cuts to a panoramic shot of the snow-capped Rocky Mountains, then zooms in on a SNOTEL monitoring station. It is April 1st, 2026, 8:30 a.m. Standard Time. This date is not arbitrary. It is the statistical peak of the mountain snowpack, the crucial volumetric measurement that determines the water supply for the entire western United States. The system is failing in real time. A federal surveyor, part of a joint team from the National Resources Conservation Service, NRCS, and NOAA, inserts a snow core tube into the ground at the Yampa View Snow Course in Routt County, Colorado. The location, established in the late 1960s, has over 50 years of continuous data. The reading is unprecedented. The surveyor extracts the tube. It contains only wet earth and dry pine needles. The recorded measurement is 0. This is not low snow, it is no snow. Similar scenes are unfolding across 64 designated snow course sites fanned out throughout the upper Colorado River basin. At 60 of these 64 critical monitoring locations, the readings are the lowest ever recorded in history. But the most alarming data points are found at 18 of these sites, absolute zero. It is now safe to conclude, based on verified geophysical data, that 2026 is the worst year for Colorado snowpack in recorded measurement history. The mountains that are supposed to act as America's largest dynamic reservoirs, capturing winter precipitation and releasing it slowly through the spring melt, are dry. A deep geophysical analysis of the upper basin reveals a catastrophic divergence from all predictive models. The statewide snow water equivalent on this April 1st, which historically medians over 14 inches, is reading an averaged 3.1 inches. The previous worst-case scenario benchmark was the historic drought year of 2012, which recorded 9.1 inches. This means 2026 has less than 40% of the water stored in its snowpack compared to the previous record low. The system that supports 40 million Americans, 5.5 million acres of farmland, and 30 tribal nations stretching from the peaks of Wyoming to the faucets of Los Angeles is now functionally broken. The magnitude of this hydrological failure is sending immediate shockwaves through the coupled human and environmental systems. Ski resorts across the Rockies, facing bare slopes and rapidly rising temperatures, are closing weeks ahead of schedule. At 11 a.m. on March 25th, the Denver Board of Water Commissioners, citing internal projections of the impending runoff collapse, declared a Stage 1 drought, implementing mandatory water restrictions for residents, ordering loan watering schedules based on address numbers, and requesting restaurants serve water only upon customer request. Further south, on the reservation of the Ute Mountain Ute tribe, the economic and cultural impact is severe. Tribal leaders have been forced to scale back all planting operations on their highly efficient, water-dependent agricultural lands because there is simply not enough physical water to grow food. This is not a projected crisis. It is unfolding simultaneously across the landscape. The Bureau of Reclamation's spring runoff forecast, which drives the operation of the entire river system, now projects that the Colorado River will deliver just 38% of its normal April through July inflow to Lake Powell. This volume is so low it triggers an immediate structural failure of the water supply chain. And 7 U.S. states, Colorado, New Mexico, Utah, Wyoming, Arizona, California, and Nevada, that share every single drop of the Colorado River, have already missed their critical federal deadline to agree on who takes the drastic mandatory cuts. The clock is ticking toward a federally imposed solution, as the essential geophysical input that sustains the entire mechanism, mountain snow, has vanished. The collapse of the Colorado River system in 2026 is not merely a byproduct of low precipitation. It is a complex geophysical failure of coupled systems. To understand why the water is vanishing faster than any model predicted, we have to look at the data coming from the SNOTEL, Snow Telemetry Network, and the USGS soil moisture sensors embedded deep in the alpine tundra. At 2:45 p.m. on March 12, 2026, the SNOTEL station at Tower in the Park Range of Colorado recorded a temperature spike of 58 degrees Fahrenheit, a reading 22 degrees above the 30-year mean for that date. This was the moment the priming of the disaster reached a critical threshold. For 3 years leading up to this crisis, the deep soil layers across the upper basin had been desiccated to their wilting point. When the meager snowpack of the 2025 to 2026 winter began to melt, the water didn't flow into the tributaries like the Gunnison or the Animas. Instead, it was instantly absorbed by the parched earth. Scientists at the Colorado Climate Center refer to this as the sponge effect. The soil moisture deficit was so profound that it effectively stole the first 2.5 million acre-feet of runoff before a single drop could reach the main stem of the Colorado River. But the destruction was also coming from above. Colorado's Dust on Snow program, which has utilized high-altitude monitoring since 2003, recorded a series of massive D-type dust events originating from the Four Corners region in February 2026. High-velocity winds stripped topsoil from the drought-stricken deserts of northern Arizona and New Mexico, depositing a dark, grit-heavy layer across the white peaks of the San Juan Mountains. This changed the albedo of the snowpack, its ability to reflect solar radiation, overnight. While clean snow reflects up to 90% of sunlight, this dust-choked snow absorbed it. The geophysical result was a melt acceleration event that moved the peak runoff date forward by nearly 45 days. By the time the official federal surveyors arrived for the April 1st measurements, the water was already gone, either evaporated through sublimation into the dry atmosphere or trapped in the subsurface soil matrix. Downstream, the Bureau of Reclamation's hydrologic sensors are recording the consequences in terrifying increments. Lake Powell, the primary regulator for the upper basin, currently sits at an elevation of 3,531 feet, representing just 24% of its total capacity. The telemetry is tracking a downward trajectory toward 3,490 feet, the minimum power pool. This is the physical limit of the Glen Canyon Dam's infrastructure. Below 3,490 feet, the water level drops below the intake penstocks for the hydroelectric turbines. If the elevation hits this line by December 2026, as current Bureau of Reclamation most probable forecasts suggest, the dam will cease to generate electricity for the first time since its completion. This is not just a loss of green energy, it is a grid stability crisis for the Western interconnection. The situation at Lake Mead, behind the Hoover Dam near Boulder City, Nevada, is even more acute. In the month of March 2026 alone, the lake's surface elevation dropped by 3.5 feet. The current reading is roughly 1,064 feet. The technical vulnerability of Hoover Dam is now the primary focus of the U.S. Army Corps of Engineers and the Bureau. The dam's 17 turbines were designed for the massive hydraulic head of a full reservoir. At current levels, the dam is operating at only 63% capacity, producing 1,314 megawatts compared to its 2,080 megawatt rating. If the water drops below 1,035 feet, 12 of the older turbine units will go offline permanently because they cannot handle the cavitation and reduced pressure. This is a structural failure of the 1922 Colorado River Compact. The agreement was based on a fundamental geophysical miscalculation. It assumed an average annual river flow of 15 million acre-feet. In reality, during the current 26-year mega-drought, the river has averaged only 12.5 million. We are witnessing the moment where the mathematical error of a century ago meets the physical reality of a dry mountain range. As Tom Bushatsky, director of the Arizona Department of Water Resources, noted in a recent emergency briefing, we are no longer managing a drought, we are managing the collapse of a regional economy. The 130 monitoring stations reading 0% are not just sensors, they are the early warning sirens for a system that has run out of time. To grasp the gravity of 2026, one must look back not just decades, but centuries. The historical precedent for what is happening across the American West is being rewritten by the Laboratory of Tree Ring Research at the University of Arizona. By analyzing core samples from ancient Douglas firs and ponderosa pines across the upper Colorado Basin, scientists have reconstructed a 1,200-year hydrological record. This data reveals that the current mega drought, which began in 2000 and has culminated in the 2026 snowpack collapse, is the driest period the region has seen since the late 1500s. But there is a more terrifying parallel: the Great Drought of the late 13th century. Between 1276 and 1299, a 23-year period of sustained desiccation forced the ancestral Puebloan people to abandon their sophisticated cliff dwellings in what is now Mesa Verde National Park, Colorado. The difference today is that we have replaced a few thousand subsistence farmers with 40 million people and a multi-billion-dollar agricultural empire. The foundation of the modern American West was built on a geophysical lie. When the Colorado River Compact was signed in 1922 at Bishop's Lodge in Santa Fe, New Mexico, the negotiators used flow data from the previous 2 decades. USGS records now confirm that the period from 1905 to 1922 was the wettest stretch in the last 1,200 years. The normal flow they used to divide the water, roughly 15 million acre-feet per year, was a statistical anomaly, a fleeting era of abundance that hasn't returned. In 2026, as the river's flow drops toward 9 million acre-feet, the system is no longer just over-allocated. It is in a state of total hydrological bankruptcy. The crisis is also triggering a profound geophysical response in the Earth's crust. This is not just about liquid water, it is about mass. As the billions of tons of water weight held in Lake Mead and Lake Powell evaporate and flow downstream, the lithosphere is responding. Data from the NSFGAGE, Geodetic Facility for the Advancement of Geoscience, network, which monitors high-precision GNSS stations across the Basin and Range Province, shows a measurable vertical crustal uplift. Around the shores of Lake Mead, the ground has risen by nearly 2.5 centimeters over the last 5 years, as the elastic rebound of the crust reacts to the removal of the reservoir's weight. This unloading of the crust has the potential to alter local tectonic stress fields. Seismologists at the University of Utah and the Nevada Seismological Laboratory are closely monitoring the intermountain seismic belt, noting that changes in pore pressure and crustal loading can influence microseismicity along dormant fault lines. The dead pool scenario is no longer a theoretical exercise for federal engineers at the Bureau of Reclamation. At Glen Canyon Dam, the dead pool elevation is 3,370 feet. If the water drops below this point, it can no longer flow out of the reservoir through gravity-fed outlets. The dam becomes a 710-foot-high concrete wall holding back a stagnant puddle of silt and toxic sediment. For the city of Page, Arizona and the Navajo Nation, this represents a total loss of access to their primary water source. The engineering challenge is unprecedented. These dams were never designed to operate at these low pressures. The 1930s Hoover Dam builders designed for a future of abundance, not a 21st century aridification. NOAA's National Integrated Drought Information System, NIDIS, has upgraded the entire Colorado River Basin to Exceptional Drought, D4. But even that label fails to capture the coupling of the failure. As the snowpack hits zero, the lack of moisture in the high-altitude forests of the White River National Forest creates a feedback loop. Dry soils and dead timber lead to higher surface temperatures, which further reduces humidity, making any future precipitation more likely to evaporate before it ever hits the ground. This is the aridification of the American West, a permanent shift in the regional climate that is rendering 20th century infrastructure obsolete in real time. The models are no longer predicting a return to normal. They are predicting the end of the West as we have known it for the last 100 years. The human and economic toll of the 2026 Colorado River collapse is no longer a projected statistic. It is a lived reality for 40 million Americans. In April 2026, as the Snowpack readings hit zero, the call on the river was officially made. This is the legal mechanism where senior water right holders demand their full allocation, forcing juniors to shut off their valves. For David Yazzie, a rancher on the Navajo Nation near Tuba City, Arizona, the crisis arrived not as a sudden flood, but as a silent, suffocating dust. For generations, his family relied on local springs, fed by the high-altitude aquifers. By May 15, 2026, those springs had stopped flowing for the first time in recorded tribal history. The Navajo Nation, which has long struggled with water infrastructure, was forced to activate its emergency water hauling program at a scale never before seen. FEMA Region 9, in coordination with the Bureau of Indian Affairs, began deploying a fleet of 5,000-gallon tankers to provide basic drinking water to over 15,000 residents whose local wells had gone bone dry. The cost of this operation alone is exceeding $1.2 million per day, a drop in the bucket compared to the regional economic fallout. In the Grand Valley of Colorado, Marcus Thorne, a 3rd century peach grower, stands in an orchard that has survived every drought since the 1930s Dust Bowl. But 2026 is different. On June 2nd, the Grand Valley Water Users Association was forced to implement a 50% reduction in deliveries. An 1890 water right used to mean you were safe, Thorne says, standing over a cracked irrigation lateral. Now it just means you're the last one to go bankrupt. The agricultural impact is staggering. In California's Imperial Valley, the winter salad bowl of the United States, the lack of Colorado River water has led to the fallowing of nearly 400,000 acres. The USDA estimates that the 2026 harvest will see a 60% reduction in lettuce, broccoli, and cantaloupe production. This has triggered a 35% spike in produce prices at grocery stores from Seattle to Miami. The total agricultural damage across the 7-state basin is currently projected to exceed $14 billion by year's end. But the most alarming threat is invisible: the power grid. At the Western Area Power Administration Operations Center in Folsom, California, lead dispatcher Sarah Chen is managing a crisis of frequency instability. On July 12, 2026, as a record-breaking heatwave gripped the southwest, the elevation at Lake Powell dropped to 3,489 feet, 1 foot below the minimum power pool. The hum of the Glen Canyon Dam's 8 massive generators, which provide 4.5 billion kilowatt-hours of energy annually, simply stopped. When Glen Canyon went dark, we lost the spinning reserve for the entire 4-state region, Chen explains. The sudden loss of 1,300 megawatts of baseload power triggered a cascading voltage dip. Across Phoenix, Tucson, and Las Vegas, grid operators were forced into rolling load shedding. In 115-degree heat, over 2 million residents experienced 4-hour blocks without air conditioning. This is a public health emergency. The CDC reports that heat-related hospitalizations in Maricopa County alone surged by 400% in the weeks following the Glen Canyon shutdown. The ecological catastrophe is equally profound. As Lake Mead recedes toward dead pool status, the retreating shoreline is exposing thousands of acres of ancient lakebed sediment. This sediment is rich in naturally occurring arsenic, cadmium, and lead, along with decades of agricultural runoff. In August 2026, a series of high wind events, known as haboobs, carried this toxic dust directly into the Las Vegas Valley and the Henderson metropolitan area. The EPA's Air Quality Index, AQI, in Las Vegas hit hazardous levels for 14 consecutive days. Schools were closed, and residents were warned to stay indoors with HEPA filters running. The long-term health implications of inhaling this toxic silt are unknown, but the immediate respiratory impact has already overwhelmed local ERs. Meanwhile, the Silicon Desert of Arizona is facing its own reckoning. The massive semiconductor fabrication plants near Phoenix, which require millions of gallons of ultra-pure water daily to cool high-end processors, have had to throttle production. Industry giants like Intel and TSMC have invested billions in water recycling, but even a 5% shortfall in make-up water from the Central Arizona Project, CAP, is enough to trigger a global supply chain disruption for microchips. The loss of industrial productivity is hitting the US GDP at an estimated rate of $350 million per week. The infrastructure of the American West was designed for a geophysical era that has ended. Every pipe, every wire, and every acre of tillable land was predicated on the presence of mountain snow. Without it, the very foundation of the Sun Belt's 21st century boom is eroding into the dust. The failure of the 2026 snowpack has moved the Colorado River from a managed shortage into a state of structural disintegration. As of September 2026, the Department of the Interior has moved into the final stages of its unilateral regulatory process. The October 1st deadline, the date by which the 7 basin states were required to reach a consensus on post-2026 operating guidelines, has arrived with no signatures on the page. For the first time in the 104-year history of the Colorado River Compact, the federal government is preparing to invoke its supreme authority under the Boulder Canyon Project Act. This is the legal nuclear option. The Bureau of Reclamation has drafted a record of decision that would bypass state water law to impose mandatory proportional cuts across the entire basin. In this scenario, California, the most senior water rights holder, would face its first ever federally mandated reduction of 1.5 million acre-feet, a volume equivalent to the total annual water use of 3 million households. The consequences of this intervention are already rippling through the U.S. judicial system. The Attorney General of Arizona and the California Department of Water Resources have both signaled intent to file emergency injunctions, potentially escalating the water crisis to the U.S. Supreme Court. But the data does not wait for the court's docket. The geophysical reality of 2027 and 2028 is already being written by the current desiccation. Climatologists at the National Center for Atmospheric Research, NCAR, in Boulder, Colorado, are identifying a locked-in negative feedback loop. Without a massive multi-year snowpack to saturate the deep mountain soils, even a normal winter in 2027 will result in below-average runoff. The earth must be quenched before the river can flow. The risk to physical infrastructure is escalating beyond the dams themselves. In Arizona, the Palo Verde Generating Station, the largest nuclear power plant in the United States, relies on a massive, consistent supply of reclaimed water for cooling. While the plant does not draw directly from the Colorado River, the regional water-energy nexus means that as urban centers like Phoenix lose their river allocations, the competition for reclaimed wastewater will become a zero-sum game. If the plant is forced to throttle production due to regional water scarcity or grid instability, the loss of its 3.9 gigawatts of baseload power would be catastrophic for the Western interconnection, potentially leading to long-term regional blackouts. Wildfire risk is the next coupled disaster. In the summer of 2026, the lack of snowpack caused the high-altitude fuels, Engelmann spruce and subalpine fir, to reach record low live fuel moisture levels by June. The U.S. Forest Service has recorded a 300% increase in lightning strike fire starts across the White River and San Juan National Forests. These fires are no longer staying in the valleys. They are burning through the timberline, destroying the very forests that shade and protect future snowpacks. This creates a black peak effect. The charred soil and soot-covered slopes will absorb even more solar radiation in 2027, ensuring that whatever snow does fall will melt even faster. The 30 tribal nations whose senior water rights predate the 1922 Compact remain the most vulnerable yet legally powerful entities in the basin. As the federal government assumes control, the Winters Doctrine, the Supreme Court precedent that guarantees tribes enough water to make their reservations a permanent homeland, will be the primary legal battleground. If the courts uphold tribal priority, the junior water rights held by major cities like Las Vegas, Tucson, and San Diego could be rendered effectively worthless. What we are witnessing is the hydraulic decapitation of the American West. The system of dams, canals, and aqueducts that enabled the 20th century boom was a feat of engineering, but it was designed for a planet that no longer exists. On the ground at the Yampa View snow course, the April 1st measurement of zero was not a fluke. It was a transition. The sensors have moved from measuring a renewable resource to documenting the final depletion of a legacy system. The reservoirs are dropping, the grid is fracturing, the politicians are litigating. But the data remains indifferent to the debate. The snow is gone, the water is not coming, and the clock has finally run out.